Cold storage, cooling load calculations. Meron tayong mga cold storage, walk-in closet, freezer, walk-in cooler. Ayan, ito yung mga pag-compute ng cooling load. Kung ilan yung tons ng evaporator mo, kung yung system. Yan, sa system, meron, ano siya, is refrigeration system din siya. Meron din evaporator, condenser, compressor, yung vapor compression system pa rin. Parts, yung parts, filter dryer, moisture indicator, solenoid valve, shut-off valve, set receiver. Ito yung mga parts ng refrigeration system. So, sa actual, malaman mo pa yung ibang mga valve parts niyan, accessories. So, TEV, ito yung thermostatic expansion valve. Then controller, so temperature sensor, kung ano yung temperature settings mo, siya ang magbi-fix nun, yung controller. Then, on-off or babado niya yung tonnage. So ito yung cold room, so may insulation, may ventilation kasi ma-pressurize man siya. So access door, so meron siyang defrosting dito sa door defrost para mabuksan mo. Now, the cooling load. The cooling load on refrigerating equipment seldom results from any one single source of heat. Rather, it is the summation of heat which usually evolves from several different sources. So, sa air conditioning, ganun din, yung cooling load ng room. So, since nauna tong refrigeration, so wag mo natin anuhin yung sa air conditioning cooling load. Dito muna tayo. So, some of more common sources of heat that supply the load on a refrigerating equipment are A, the heat that leaks into the refrigerated space from the outside by conduction through the insulated walls. So, may init siya. Kasi may insulation siya, hindi mag-zero yan. Okay? B, the heat that enters the space by direct radiation through glass or other transparent materials. Kung meron kang sa cold room mo o sa cold storage mo, meron kasi mga warehouse type na malalaki. So, meron siya mga bintana. Heat that is brought into the space by warm outside air entering the space through open doors or through cracks around windows and door, yung mga infiltrations. D, heat given off by warm product as its temperature is lowered to the desired level. So, ito yung importante, yung product mo. Heat given off by people occupying the refrigerated space. So, minsan may tao yan, di ba? Pumapasok, simple kukuha nung, kasi storage, kukuha nung product. Okay. F, heat given off by any heat-producing equipment located inside the space, such as electric motor, lights, electronic equipment, steam tables. Hindi yan yung, hindi yan yung steam table natin, coffee urns, and hair dryer. Kung may equipment ka doon. So, motor. Kasi motor, may andyan yung nasa loob yung pan, yung equipment, may motor yon, kasama mo yon. Lights, may ilaw yan. Okay? Now, equipment running time. Although refrigerating equipment capacities are normally given in BTU per hour, di ba yung capacity, in refrigeration application, the total cooling load is usually calculated for 24 hours, hindi 365 days. So, that is in BTU per 24 hours talaga yon. So then, to determine the required BTU per hour capacity of the equipment, the total load for the 24-hour period is divided by the desired running time for the equipment. So required BTU per hour, equipment capacity sa total cooling load, BTU per 24 hours divided by the desired running time. Check at kinestong ko na to. Wait lang. Yung mag-pause. Yun. So, okay. So, ito nga lang. Ang kinukompute mo is 24 hours period yung cooling load ng isang product. Ayan. That is the, tapos ito naman is the desired running time ng equipment. Okay? Simple lang, alangan mag-isabay mo. So, this running time, ang 8, so yun na yung running time niya. So, mag-ano na lang siya yung magme-maintain. So, because of the necessity for defrosting the evaporator at frequent intervals, kasi mababa lang naman, it is not practical to design the refrigerating equipment in such a way that the equipment must operate continuously in order to handle the load. In cases where it is inconvenient to calculate the refrigeration load on a 24 hours basis, the load may be determined directly in BTU per hour provided that the result is multiplied by an appropriate factor which makes an allowance for the desired equipment operating time. So where the desired equipment operating time is 16 hours out of 24, the refrigeration load in BTU per hour should be multiplied by 24 over 16 or 1.5, which in effect increase the required equipment capacity by 50%. So that the equipment selected will have capacity to handle 24 hours cooling load in the required 16 hours of operating time. Similar multipliers can be determined for other desired operating time. Okay? So cooling load calculations. To simplify cooling load calculations, the total cooling load is divided into a number of individual loads according to the sources of heat supplying the load. The summation of this individual load is the total cooling load on the equipment. Ito yung detailed. In commercial refrigeration, the total cooling load is divided into 4 separate loads. The wall gain load. Okay. The air change load. Ito yung hangin na labas-pasok sa required ventilation. The product load. Yung product mo. Yun ang main point mo doon. For miscellaneous or supplementary load. Yung mga ilaw, etc. etc. Okay. So the wall gain load. So the wall gain load, sometimes called the wall leakage load, is a measure of the heat flow by conduction through the walls of a refrigerated space from the outside to the inside. Since there is no perfect insulation, there is always a certain amount of heat passing from the outside to the inside whenever the inside temperature is below that of the outside. So the wall gain load is common to all refrigeration application and is ordinarily a considerable part of the total cooling load. So wait, doble. Now the air change load. When the door of a refrigerated space is open, warm outside air enters the space to replace the more dense cold air, which is lost from the refrigerated space through the open door. The heat which must be removed from this warm outside air to reduce its temperature and moisture content to the space design condition becomes a part of the total cooling load on the equipment. This part of the total cooling load is the air change load. Then the product load. The product load is made up of heat that must be removed from the refrigerated product in order to reduce the temperature of the product to desired level. The term product as used here is taken to mean any material whose temperature is reduced by the refrigerating equipment and includes not only perishable commodities such as foodstuff, but also such items as building electrodes, masses of concrete, plastic, rubber, and liquid of all kinds. In some instances, the product is frozen, in which case the latent heat removed is also a part of the product load. Yung latent heat, ito yung mga sa freezer. Okay? Yung sa chilling. Chilling, hindi naman nagbaba ng freezing point. Now, the miscellaneous load. Miscellaneous load, sometimes referred to as supplementary load, takes into account all miscellaneous sources of heat. Chief among these are people working in or otherwise occupying the refrigerated space, along with lights or other electrical equipment operating inside the space. In most commercial refrigeration applications, the miscellaneous load is relatively small, usually consisting of only of the heat given off by lights in fan motor used in the space. Okay. So, factors determining the wall heat gain. Pag-compute. The quantity of heat transmitted to the walls of a refrigerated space per unit time is the function of three factors whose relationship is expressed in following equation, where Q is equal to A, U, D. A Q, quantity of heat transferred in BTU per hour. A, the outside surface area of the wall, square feet. U, the overall heat transfer coefficient of heat transmission in BTU per hour per square foot per degree Fahrenheit. D, the temperature differential across the wall in degrees Fahrenheit. The coefficient of transmission of U factor is a measure of the rate at which heat will pass to a 1 square foot area of wall surface from the air on one side to the air on the other side for each 1 degree Fahrenheit of temperature difference across the wall. The value of the U factor is given in BTU per hour and depends on thickness of the wall and on the material used in wall. So example number 1, determine the total quantity of heat in BTU per hour which will pass to a wall 10 feet by 20 feet. If the U factor for the wall is 0.16 BTU per hour square foot Fahrenheit and the temperature on one side of the wall is 40 Fahrenheit while the temperature on the other side is 95 Fahrenheit. Given the wall dimension 10 feet by 20 feet, U is 0.16 BTU per hour square foot Fahrenheit. Lower temperature 40 Fahrenheit, higher temperature 75 Fahrenheit. Required Q is the heat gain through the wall. Solution. Find the total wall area is 10 by 20 is 200 square feet. The temperature differential across wall Fahrenheit is D is equal to 95 minus 40 or 25 Fahrenheit. And the heat gain through the wall is Q is equal to A times U times D or 200 times 0.16 times 55 is 1760 BTU per hour. To determine the wall gain load in BTU per 24 hours as required in refrigeration load calculation, the result is multiplied by 24 hours. Hence, for calculating cooling loads and refrigerating application, to include this multiplication is Q is equal to A U D times 24. A times U times D times 24. Now, determination of the U factor for the wall, the overall coefficient of transmission or U factor have been determined for various types of wall construction and these values are available in tabular form. Nandiyan sa tables 1 through 3 ang mga value for various types of cold storage wall. So ito yon, combination, vapor seal, wall sa corkboard. Ito yung mga combination niya. Ito yung mga wall thickness and thickness of insulation. So andyan yung BTU per hour per square foot per degree Fahrenheit difference between air on the two sides. Yeah. And mga thickness ng insulation, ito yung value mo. Okay? And this is applicable for wind velocity of 15 miles per hour. Okay? Reference is siyempre yung carrier. Table 2, heat transmission coefficient U for cold storage. So parehas siya. This is now naman BTU per hour per square foot per degree Fahrenheit difference between the air on two sides. Outside wind velocity 15 miles per hour. Ayan, lahat yan. Continue, tuloy-tuloy lang yan. Hinihiwa-hiwalay lang ng reference yung tables. Numbering. Okay? So table 4 also list the thermal conductivity or the conductance of some material frequently used in the construction of cold storage wall. Kung wala doon sa table 1 to 3, so mag-iisa-isa ka. Okay? I-transfer nyo. Yan. The thermal conductivity or K factor of a material is the rate in BTU per hour at which heat passes through 1 square foot cross-section of the material 1 inch thick for each 1 Fahrenheit of temperature difference across the material is given in BTU per hour per square foot per degree Fahrenheit per inch thick. Kasi ang thickness mo is in inches. Okay? Masonry, wood, mga materials, roofing, sa bubong. So, insulating materials, glass, meron ka. So, andyan yung mga value. Okay? When the thermal conductivity or K factor is available only for homogeneous material and the value given is always for 1 inch thick of the material, the thermal conductance or C factor is available for both homogeneous and non-homogeneous material and the value given in BTU per hour per square foot per degree per is for the specified thickness of material. Ito. Ito, wala siya dito, di ba? So, ito is para dito sa 4 inches. Ito naman sa 0.9. Okay? So, for any homogeneous material, the thermal conductance can be determined for any given thickness of the material by dividing K factor by the thickness in inches. Hence, for homogeneous material, C is equal to K over X, where X thickness of material in inches. So, pare-paras. Since the rate of heat transmission through non-homogeneous materials such as concrete building block as in figure Y kasi may airspace siya. So, will vary in the several part of the material. So, the C factor from non-homogeneous material must be determined by experiment. Or, yung analytical, pwede rin. Kasi basta kabisado mo na yung mga properties niya. So, the resistance that a wall or a material offers to the flow of heat is inversely proportional to the ability of the wall or material to transmit heat. Hence, the overall thermal resistance of a wall can be expressed as the reciprocal of the overall coefficient of transmission. Whereas, the thermal resistance of an individual material can be expressed as the reciprocal of its conductivity or conductance. That is, overall thermal resistance is R is equal to 1 over U. Now, the thermal resistance of an individual material is equal to 1 over K or 1 over C or X over K. So, the terms 1 over K and 1 over C express the resistance to heat flow to a single material from surface to surface only and do not take into account the thermal resistance of the thin film of air which adheres to all exposed surfaces. And determining the overall thermal resistance to the flow of heat to a wall from the air on one side to the air on the other side, the resistance of the air on both sides of the wall should be considered. That is, air perm coefficient or surface conductance for average wind velocities are given in table 4. Sana yun? Table 4. Ito. So, yun ang idadagdag mo. Okay? Heat transfer tayo. So, when a wall is constructed of several layers of different material, the total thermal resistance of the wall is the sum of the resistances of the individual material in the wall construction, coding air terms. That is 1 over U is equal to 1 over Fi plus X1 over K1 plus X2 over K2 plus and so on, Xn over Kn plus 1 over Fo. Therefore, U is equal to the reciprocal nyon, where 1 over Fi is the convective coefficient sorbent conductance of inside wall, floor, or ceiling. 1 over Fo is equal to the convective coefficient surface conductance of outside wall, floor, or roof. Yeah. Note when sa AR, may depend sa AR. Note when non-homogeneous material are used, 1 over C is substituted for X over K. So example number 2. Assuming a wind is velocity of 7.5 miles per hour, calculate the value of U for wall constructed of 8-inch cinder aggregate building block insulated with 4 inches of corkboard and finished on the inside with 0.5 inches of cement plaster. Given the wind velocity. Construction. 8-inch cinder aggregate building block insulated with 4 inches of corkboard and finished on the inside with 0.5 inches of cement plaster. So, on the inside. So, meron, after ng yung cement plaster, ando na yung air film mo. Merong outside naman dito bago mag-aggregate. So from table 4, so 8-inch cinder block is C is 0.58, corkboard 4.3, cement plaster is 5-inch. Inside convection coefficient is Fi is 1.65. Ito. Outside convection coefficient is 4.0, 7.5 miles per hour. So apply the equation for the overall thermal resistance. 1 over U. So ito yung formula. Substitute na lang natin. 1 over 4. Nabaliktad yung pagkalagay. Okay, this is ano? Nabaliktad lang siya. This is 1 over 0.58 plus 4 over 0.3 plus 0.5 over 5 is plus 1 over 1.65 is 16.01. Therefore, U is equal to 0.062. Baliktad yung books to sa libuhan. Hindi ko napansin. Now, determine, for the most part, it is the insulating material used in the wall construction that determines the value of U for cold storage wall. Diba? So the surface conductances and the conductances of other material in the wall have very little effect. So we neglect on the value of U because the thermal resistance of the insulating material is so large with relation to that of the airframe and other material. Therefore, for small coolers, it is sufficiently accurate to use the conductance of insulating material alone as the wall U factor. For small coolers, ito yung temperature gradient. The temperature gradient through a typical cold storage wall is illustrated in figure 2. Okay. Notice that the temperature drop difference 70 and 20 across the individual wall component is proportional to the thermal resistance offered by that component, and that the overall thermal temperature drop differential across the wall is summation of the individual temperature drop across the several wall component. So yan, ang delta T nito is 0.75. Ito naman is 5.4. So ito 41.65 to 0.3, then 1.9. So i-add mo to, minus mo doon is magiging 20. Yan. So hindi yan diretso Okay. Now next, temperature difference across the cold storage wall. Parang yung climate. So the design temperature difference across cold storage wall is usually taken as the difference between the inside and outside temperatures. So the inside temperature is that which is to be maintained inside the refrigerated space and usually depends upon the type of product to be stored and the length of time the product is to be kept in storage. So the recommended storage temperature for various products are given in table 10 to 13. So this is the table 10 is design data for fruit storage. Ay na tatlong fruit. Nasaan? Iusong ko lang. Yan. So dito, apples, apricots, avocados, ayan, lahat ng type. Type of the storage, short, long, chill start, chill finish. So yung mga tawag dyan. Yung short storage. Ano ito yung mga recommended temperature, design room conditions. So, and Fahrenheit, na 35 to 40. So, relative humidity, may recommended yan. Apples, moist, di ba? So, maximum storage period, 18 to 8 months yata to. So, 7 to 14 days yung apricots. Ano ito siya? Maximum storage period. Di ba? Kaya yung apple nga, kung ilang buwan pa bago mag-December, saka yan. Chilling product. So, yung chilling mo lang, ito. Ito ang value mo sa chilling. So, estimated product latent heat. Ito kung mag-freeze ka. Next is the specific heat. Yan sa cooling. Diba? Before freezing. O sa before freezing ito. After freezing na. So, magkukul ka pa. Ito naman value. Yan. At the heat of fusion. So, pag may freezing ka, idadagdag mo to. Water content. Okay. Then, freezing point. So, ayan. Paano malaman kung freeze siya? So, pag nasa dito ka sa temperature na to, so freezing ka na. Okay? Maximum air motion. So, sa ano niya, sa ibabaw. Yan. Ito naman, design data for vegetable storage. Yan. Design room conditions. Ito yung mga vegetable mo, chilling data. Yan, specific heat. Ganon din ang mga value. Okay? So ito naman, vegetable. Andyan yung mga data niya. Table 11 continuation. Then, table 12. Ganon din. Ito naman, design data for meat storage. Then for other storage, andito. Beer, waiter, candy, carrier. Andyan naman siya ano yan. Okay? Yan. Table 13. So the outside design temperature naman depends on the location of the cooler. For cold storage wall located inside the building, the outside design temperature for the cooler wall is taken as the inside temperature of the building mismo. Okay? When the cold storage wall are exposed to the outdoor design temperature for the region, table 5 is used as the outside design temperature. Para sa aircon. Kung ano, so wala pa tayong aircon, di ba? The outdoor design temperature given in table 5 are average outdoor temperature and include an allowance for normal variation in the outdoor design dry bulb during 24-hour period. This temperature should not be used for calculating air conditioning load. So kasi 24-hour lang to, di ba? So table 5, refrigeration design ambient temperature guide. So location niya Alabama, ito US to, di ba? Ambient maximum, yung ground temperature, yan. Ground temperature yung kinapakan mo. So table 5, ito yung mga location US to, okay? Yan. And do not use this temperature for air conditioning design. Okay. So, temperature differential across ceiling and floors. When a cooler is located inside a building, there is adequate clearance between the top of the cooler and the ceiling of the building to allow free circulation of air over the top of the cooler. The ceiling of the cooler is treated the same as the inside wall. Okay, inside temperature. Likewise, when the top of the cooler is exposed to outdoor, the ceiling is treated as outdoor wall. The same holds true for floors except when the cold floor is laid directly on a slab on the ground. So meron tayong ground temperature, di ba? As a general rule, the ground temperature under a slab varies only slightly the year round. Is always considerable less than the outdoor dry bulb temperature for the region in summer. Ground temperature used in determining the temperature differential across the floor of the cold storage are given in table 5 and are based on regional outdoor design dry bulb temperature. So now, effect of solar radiation. So when the walls of a refrigerator are so situated that they receive an excessive amount of heat by radiation na kapag sa araw o sa labas mo nilagay, either from the sun or from some other hot body, the outside surface temperature of the wall will usually be considerably above the temperature of the ambient air. Since any increase in the outside surface temperature will increase the temperature differential across the wall, the temperature differential across sunlit walls must be corrected for sunlit walls given in table 6. So allowance for solar radiation. So degrees to be added to normal temperature difference for heat leakage calculation to compensate for sun effect. Not to be used for air conditioning design. Yan. Ito yung mga type of surface. So i-add mo ito kung na east, south, west. I-add mo yan. Flat roof, 20. Okay, these values are added to the normal temperature differential. For walls facing at an angle to the direction listed in table 1, average value can be used. Now, calculating the wall gain. In determining the wall gain load, the heat gain through the walls, including the floor and ceiling, should be taken into account. When the several walls or part of walls are of different construction and have different Q factor, the heat leakage through the different parts is computed separately. Walls having identical U factors may be considered together, provided that the temperature differential across the walls is the same. So 2, where the difference and the value of U is slight and or the wall area is small, the difference in U factor can be ignored and the walls or parts of the wall can be grouped together for computation. So example number 3. A walk-in cooler 16 feet by 20 feet by 10 feet high is located in southeast corner of a store building in Dallas, Texas. Figure this, southeast. Diba? So sabihin natin na sa southeast siya. Corner. The south and east. The south and east wall of the cooler are adjacent to a part of the south and east wall of the store building. The store has a 14-feet ceiling so that there is a 4-feet clearance between the top of the collar and the ceiling of the store. Okay. The store is air conditioned and the temperature inside the store is maintained at approximately 80 Fahrenheit. So the inside design temperature for the collar is 35. Determine the wall gain load for the collar if the walls of the collar are of the same following construction. Sun and east, outside walls, meron tayong 6-inch clay tile, 6-inch corkboard, 0.5 cement plaster, finish on inside. Inch yan. North and west are inside walls with 1-inch board on both sides of 2x4 studs, 3 and 5/8-inch granulated cork. Ceiling, same as north and west wall. Ito, maras. Floor, 4-inch corkboard laid on 5-inch slab and finished with 3-inch concrete. Yung side niya. So, cubes na siya, di ba? O box. Given niya ito, 16 feet by 20 feet by 10 feet high. Southeast, the south and east wall of the collar are adjacent to a part of south and east wall of the store building. 14 feet ceiling, 4 feet clearance, 80 Fahrenheit store. Inside the sun temperature for the collar is 35 Fahrenheit. So ito yun. Inside niya. So required the wall gain load for the collar. So total niyang wall. Pati floor. So north wall is 10 by 16 is 160 square feet. West wall is 10 by 20, 200 feet. South wall is 10 by 16. Ito. So east wall, ceiling, 16 by 20. Floor, ganun din. So wall U factor sa table 1, 2, 3, makukuha mo doon yung north and west wall is 0.079. So wala squared to. Wait na. South and east wall, 0.0545. Then ceiling, 0.079. Floor is 0.05. Check mo sa table 1, andun yung mga materials niya, di ba? Yan. Given yung materials. Okay. Hanapin mo doon, nagkataon na meron doon. So, makukuha mo yung value. Kung wala, isa-isahin mo yan. Northeast wall. Hanapin natin, Nakita ko lang. Ang layo na. Point zero. Andito yung pagkuha niya. Okay. Yung ata, 0.079. Yun. Tama. Okay. 0.079. Check nyo na lang. Wala nang ikutin. Ayan. Tama. Okay, cos 6-inch corkboard, 3 and 5/8. So ito, pag neglect na lang yung iba. Kung check na lang ulit doon. So insulation. So insulation kinuha. So from table 5, outside design temperature $4.92. Design ground temperature $4.70 Fahrenheit kasi meron tayong floor. When applying, so 160 times 0.079 times 45 is 569 meter per hour. East wall is 200 times 0.045 times 567. Equals 567. South wall is 439. West wall is 711. Ceiling is, and then 1138. Floor is 17. And total is 4,163 meter per hour. For 24 hours, this is 99,112 meter per hour. 24 hours. Okay. So the area, wala. is the outside dimension. Okay? So, ito sa cold storage. Pero sa aircon, that is inside dimension. Ang ginagamit ko. Kasi dito ang proof, ayan, 16 by 20. Now, calculating. A short method may be used to determine the wall gain load for small coolers only and for large cooler where the U factor and temperature difference are approximately the same for all the walls. Yan. Assuming lang. So, para hindi ka na magpare-parehas, so, pero mayroong namang shortcut. Kaya lang, iwas lang yung shortcut, baka may iba palang materials, okay? So, table 7 list wall gain factors, BTO per 24 hours per square foot based on the thickness of the wall insulation and on the temperature differential across the wall. So, this is now the cork or equivalent insulation, temperature difference. Yan. So, kukuha mo yung value. Yan. Wall heat sa wall per square foot of the wall. Okay, ito naman yung mga glass. To compute the wall gain load in BTO per 24 hours by the short method, multiply the total outside wall area, including floor and ceiling, by the appropriate wall gain factor from table 7. So, wall gain load is outside surface area times wall gain factor. Now, to select the appropriate wall gain factor from table 7, find the thickness of the wall insulation in the extreme left-hand column of the table. Move right to the column head by the design for temperature difference and read the wall gain factor in BTU per 24 hours per square foot. For a sample, assuming that the walls of the color are insulated with the equivalent of 4 inches of corkboard and that the temperature difference across the wall is 55 Fahrenheit. From table 7, read the wall gain factor of 99 BTU per 24 hours per square foot. 55? Saan yun? And 4 inches, so ayan, 99. Okay? So next, calculating now the air change load. Tapos tayo sa wall. So the space heat gain resulting from air changes in the refrigerated space is difficult to determine with any real accuracy, except in those few cases where a known quantity of air is introduced into the space for ventilating purposes. Yan, sa sa alam mo. When the mass of outside air entering the space in 24-hour period is known, the space heat gain resulting from the air changes depends upon the difference in the enthalpy of the air at the inside and outside condition and can be calculated by applying the following equation. Air change load is equal to M times H sub O minus H sub I, where M is the mass of air entering the space in 24 hours. H sub O enthalpy of outside air BTU per pound. SI is enthalpy of inside air BTU per pound. So, however, since air quantities are usually given in cubic feet rather than in pounds, to facilitate calculation, the heat gain per cubic feet of outside air entering the space is listed in table 8A and 8B for various inside and outside air condition. To determine the air change in BTU per 24 hour, multiply the air quantity in cubic feet per 24 hour by the appropriate factor from table 8A and 8B. So, ito yun. Table 80 is the BTU per cubic feet of air removed in cooling the two storage conditions. Cubic feet of air is yung volume ng room. The storage temperature, kukunin mo yung inlet air, Fahrenheit, ano yung humidity. So, ito yung factor mo. Okay? So, this is above 30 C, Fahrenheit. Ito naman, B is below 30 Fahrenheit. So, example number 4. 300 cubic feet per minute of air are introduced into a refrigerating space for ventilation. If the inside of the cooler is maintained at 35 Fahrenheit and the outside reliable temperature and humidity are 85 and 50% respectively, determine the air change and BTU per 24 hours. So given 300 CFM of air, 35 Fahrenheit inside temperature, 85 Fahrenheit outside reliable temperature, and 50 Fahrenheit outside relative humidity. Required air change load. So the volume is, andyan naman, 300. So CFM times 60 times 24, or 300 times 60 times 24 is 432,000 cubic feet per minute. after 24 hours. So from table 8A, the air change factor is 1.86. So multiply mo yon. So magiging 803,520 BTU per 24 hours. This is now the air change load. So table 9A and 9B list the approximate number of air changes per 24 hours for various color size. So ito naman is may volume, makukuha mo na yung air changes per hour. Okay? Mga shortcuts. So kapag detailed, so doon ka sa mga sa una nating discussion. So the values given are for average usage. So the ASTE data book defines average and heavy usage as follows. Average usage includes installation, not subject to extreme temperature, and where the quantity of food handled in the refrigerator is not abnormal. Heavy usage includes installations such as those in busy markets, restaurant, and hotel kitchen, where the room temperature are likely to be high, where last period place heavy loads on the refrigerator, and where large quantities of warm food are often placed in it. So ito yung isa, table 9 is above 32 Fahrenheit, and ito naman is below 32 Fahrenheit. Okay. So note that does not apply to rooms using ventilating ducts or grills. So volume, air changes, and 250 cubic feet to 200,000 cubic feet. Ito naman, 252, ganun din. Okay. Yan yung mga value. May mga notes. For storage room with anti-room, reduce air changes 50% of the value on the table. For heavy usage, add 50% to the values given in the table. So yan. Okay. So calculating the product load. So mga reviewers, when a product enters a storage space at a temperature above the temperature of the space, the product will give off heat to the space until it cools to the space temperature. When the temperature of the storage space is maintained above the freezing temperature of the product, the amount of heat give off by the product in cooling to the space temperature depends upon the temperature of the space and upon the mass, specific heat, and entering temperature of the product. So in such cases, the space heat gain from the product is computed by the following equation. Q is equal to MC delta T. So Q, quantity of heat in BTU, and mass of the product. C is the specific heat above freezing. Delta T is the change in the product temperature. Yan. So wala pang ano doon, latent heat na. So chilling rate factor. During the early part of the chilling period, the BTU per hour load on the equipment is considerably greater than the average hourly product load because of the high temperature difference which exists between the product in the space air at the start of the chilling period. The chilling rate is higher and the product load tends to concentrate in the early part of the chilling. So the chilling rate, therefore, where the equipment is based on the assumption that the product load is able to the chilling period, the equipment selected will usually have insufficient capacity to carry the load during initial stages of the chilling when the product load is at peak. Yung masa chilling lang to So to compensate for the uneven distribution of the chilling load, a chilling rate factor is sometimes introduced into the chilling load calculation. Yeah. The effect of chilling rate factor is to increase the product load calculation by an amount sufficient to make the average hourly cooling rate approximately equal to the hourly load at the peak condition. This results in the selection of larger equipment having sufficient capacity to carry the load during initial stage of chilling. So, chilling to. So chilling rate factors are usually applied to rooms and dito siya chilling data. Ayan yung chilling rate factor. Are usually applied to chilling rooms only and not normally used in calculation of product load for storage room. Storage, problema storage. Store lang naman. So chilling, walang problema. Ito chilling naman, ito may maintain ka. Chilling rate factor for various product are listed in table 10 to 13. The factors given in tables are based on actual tests and on calculation and will vary with the ratio of the loading time to the chilling rate. So ito yung mga value. Ulit na ulit lang, no? Ayan yung chilling rate factor. Yan. So, ulit-ulit. Now, product freezing and storage. So, when the product is to be frozen and stored at some temperature below its freezing temperature, the product load is calculated in three parts. A, the heat given off by the product in cooling from the entering temperature to its freezing. B, the heat given off by the product on solidifying or freezing. C, the heat given off by the product in cooling from its freezing temperature to the final storage temperature. So, the product load resulting from the freezing B is calculated from the equation M is equal to SIF. So, SIF is the product natin load in BTU per pound. Alam niyo, di ba? Minsan yung paggawa ng yelo, yan din yan. Sa yelo, common yun, di ba? So, when the chilling and freezing are accomplished over a 24-hour period, the summation of the three parts represent the product load for 24 hours. So, when the desired chilling and freezing time for the product are less than 24 hours, the summation of the three parts is divided by the desired processing time and then multiply by 24 to determine the equivalent 24 product load. So example number 5, 500 pounds of poultry enter a chiller at 40 Fahrenheit and are frozen and chilled to a final temperature of -5 Fahrenheit for storage. So storage to in 12C. Compute the product load and BTU per hour, 24 hours. So given 500 pounds of poultry, chiller at 40 Fahrenheit, frozen and chilled to 5 Fahrenheit, storage is 12 hours. Yeah. Required product load and BTO per 24 hours. Solution. Table 11, the specific heat above freezing is 0.09. No poultry, the specific heat below freezing is 0.37. Normally, hati yan, kalahati. Yung sa below freezing. Latent heat is 106. So, freezing temperature, doon din sa table galing to, 27C. Now, to cool poultry from entering temperature to freezing temperature, we have 500 times 0.79 times 40 minus 27 is 5135. To freeze, so 500 times 106 is 53,000 BTU. To cool from freezing temperature to final storage temperature is 500 times 0.37 times 27 minus -5 is 5,920. Therefore, the equivalent product load for 24 hours is 64,000 times 24 over 12 is, i-add mo to, 5135 plus 53 plus 5920 is 64,055 times 24 over 12 is 128,110 BTU per 24 hours. So, ito yung equipment load mo. Respiration heat. Fruits and vegetable. So, mula sa meat, sa fruits, sa fruits lang, fruits and vegetable are still alive after harvesting and continue to undergo changes while in storage. Huminga pa. Respiration. The more important of these changes are produced by respiration, a process during which oxygen from the air combined with the carbohydrates in the plant tissue and result in the release of carbon dioxide and heat. The heat release is called respiration heat and must be considered as part of the product load, where considerable quantities of fruit and or vegetable are held in storage at temperature above doon. The product load. The amount of heat evolving from in respiration classes depends upon the type and temperature of the product. Respiration heat for various fruits and vegetable is listed in table 14. So yan, fruits, vegetable, ano ito mga value niya, BTU per hour, temperature. Ito yung ano. Since respiration heat is given by in BTU per pound per hour, the product load accruing from respiration heat is computed by multiplying the total mass of the product by the respiration heat as given in table 14. Q is BTU per hour, 24 hour is mass of product pounds times respiration heat, BTU per pound per hour times 24. Okay? Ayan. May example na tayo. Containers and packing material. When a product is chilled in containers such as milk and bottle or cartons, egg and crates and fruit and vegetable and basket and lugs, the heat given off by the containers and packing material in cooling from the entering temperature to this space must be considered as part of the product load. Siyempre. So, calculating miscellaneous load. Yeah. The miscellaneous load consists primarily of the heat given off by lights and electric motors operating in the space and by people working in the space. The heat given off by the lights is 3.42 to 3.416, yan, di ba? 3.42 BTU per watt hour. The heat given off by the electric motors and by the people working in the space is listed in table 15 and 16. Ito yung motor and people. Andito siya. Color temperature. Ayan. So, ang heat equivalent per person ito. Okay. So, motor losses. And then, may notes. Basahin na lang yan. So, the following calculation are made to determine the heat gain from miscellaneous lights. Wattage, 42 BTU per watt hour times 24. Electric motor is the factor, table 14. Horsepower times 24. Use of safety factor. So the total cooling load for a 24-hour period is the summation of the heat gain as calculated in foregoing section. It is common practice to add 5% to 10% to this value as a safety factor. As a general rule, or simply 10% is used. After the safety factor has been added, the 24-hour load is divided by the desired operating time for the equipment to determine the average load in BTU per hour. Short method calculation. So, when coolers are used for general purpose storage, the product load is frequently unknown and or varies somewhat from day to day so that it is not possible to compute the product load with any accuracy. In such cases, a short method of load calculation can be employed. So, pag wala ka pang mga product, di mo ma-identify sa mga product. So, meron tayong wall gain load and the usage or service load. The wall gain load is calculated as before. The usage load is computed by the following equation. So, usage load is interior volume times the usage factor. Notice that the usage factor listed in table 17 vary with interior volume of the cooler and with the difference in temperature between the inside and outside of the cooler. Tawag niya cooler, ha? Cooler to. Yan. So, coolers to, hindi to freezer. So, 2, an allowance is made for normal and heavy usage. No factor of safety is used when the cooling is calculated by the short method. The total cooling load is divided by the desired operating time for the equipment to find average hourly load used to select equipment. Example number 6. A walk-in cooler, 18 feet by 10 feet by 10 feet high, has 4 inches of corkboard insulation and 1 inch of wood on its side. Total thickness 6 inches. The temperature outside cooler is 85 Fahrenheit. 3,500 pounds of mixed vegetable are cooled 10 degrees Fahrenheit to the storage temperature each day. Compute the cooling load in BTU per hour based on 16-hour per day operating time for the equipment. The inside temperature is 40 Fahrenheit. Usage is heavy. Given. So 18 feet by 10 feet by 10 feet high. 4-inch corkboard insulation and 1 inch of wood on each side. Total wall thickness is 6 inches. 85 Fahrenheit temperature outside the cooler. 40 Fahrenheit inside temperature. 3,500 pounds of mixed vegetable cooled to 10 Fahrenheit. Required is the cooling load in BTU per hour based on 60 an hour per day solution. Outside wall area, outside face area is 4 times 18 feet times 10 feet plus 2 feet times 10 feet is 920 square feet. Inside volume, since the total wall thickness is 6 inches, the inside dimension are less than 1 foot less than the outside dimension. So, 17 feet times 9 feet times 9 feet. So, inside the volume, so 1377 cubic feet. The wall gain factor is stable 7 times 45 Fahrenheit times 5 and 4 inch insulation. And 4 inch insulation, this is 81 BTU per square foot per 24 hours. Air change, table A9 by interpolation is 14.9 with per 24 hours. The heat gain per cubic foot of air, table 87A, 50% RS is 1.69. Average dispersion of heat of vegetable is 0.09 BTU per pound per hour. So, ito nga, average respiration heat of vegetable level 14 is 0.09 BTU per pound per hour. Okay. Nakulit lang. Last page na lang. Ito, last page na eh. Nag-loading. Yan. Okay. So, the wall heat load is the area times the wall gain factor. So, 920 times. Ito. Ayan. Ito. Last na lang to. Last na to. Wait natin. So, ito na. 74,500 BTU per 24 hours. Air change load naman is inside volume times the air changes times air change factor is 1377 cubic feet. That's 14.9 times 1.69 BTU per cubic feet is 4,700 BTU per 24 hours. Now, the product load is temperature reduction is MC times delta T, 35 times 0.9 times 10, or 31,500. Then respiration heat is the mass times reaction heat times 24 is 35 times 0.09 times 24 is 7,600 BTU per 24 hours. So summation mo, 74,500, 34,700 plus 31,500 plus 7,600 is 148,300 BTU per hour, 24 hours. City factor 10% is 14,800. So, may 30 pa yan. Okay lang. Round up na lang niya. Significant figures. Total calling load is 163,100 BTU per 24 hours. Now, the required calling capacity for 16 hours is the calling is 163,100 times 24 over 16 is ito, 10,200 BTU per hour. This is for 24 hours equivalent. Okay? So, this is now the cooling load for short storage. So, thank you very much. Ito yung ano pala, ito yung unit cooler. Yan, mayroon din iba niya sa ibabaw. So, ito yung mga pinapalamig. Okay? Ang condenser niya sa taas, ibabaw, outside. Thank you.